Here we're asked to use transformations to graph f of x equals 2 to the x power minus 3, identify the domain, range, horizontal asymptotes, and find the open intervals of x values where the function is increasing or decreasing. Solutions. Part of it's already written, but we'll get to that eventually. We're going to be using note number 92, where we list basic graphs of the exponential function. And for that note, number 92, we have the precise basic function f of x equals 2 to the x. And it looks like this. It has the y-intercept at 0, 1. That's xy equals 0, 1. Passes through that, and it's asymptotic to the x-axis. That's the equation, y equals 0. That's the equation for the x-axis. We'll also use note number 47, part A, the corrected version of part A, which says if you want to graph from the basic function f of x, a variation g of x equals the basic f of x plus c, that would imply that when c is equal to a negative number, which it will be in this case, that means you're going to shift the basic graph c units downward. So in our problem, we have f of x equals 2 to the x minus 3. And that means our basic graph will be 2 to the x, and the negative 3 that's being added at the end means from note 47 that we will shift our basic graph 3 units downward. So here we are drawing the picture of the asymptote 3 units below its original position in the basic graph, f of x equals 2x. And then we're locating the y-intercept 3 units down from its original position from 1 down to the position negative 2. And then we're going to go ahead and draw the same asymptote. See, the original asymptote was at the location y equals 0, and the original y-intercept was 0, 1. Now the asymptote is located at y equals negative 3, and the y-intercept's at 0, negative 2. So here's our picture shifted down 3 units. It was really easy just to shift the original picture down. Now let's answer the rest of the question. The domain, all the possible x values in this graph. Well, from the arrows on each end of the graph, we can see that it goes on forever in both directions. So it covers all x values from negative infinity to infinity. For the y values, the lowest y value is almost negative 3, so it's open negative 3 to infinity for y values. The horizontal asymptote is located at the horizontal line y equals negative 3, and it's increasing the entire time. As you move from left to right, it's increasing upward. So the function increases on the open interval of x values from negative infinity to positive infinity.